right, Chip Kids, today's adventure takes us to Boise State University, right here in Idaho. And guess who we're teaming up with? Micron. This company started in the basement of a dentist's office and grew into one of the world's leaders in computer memory chips. They've given us a challenge: design a solid-state drive.
I need more power.
SSDs are fast, efficient, and built with no moving parts. But the real question is, what will it be used for? A self-driving car? A gamer's dream machine?
For gamers.
Your mission: design it, pitch it, and see if the Micron pros will say, yes, let's build it, or back to the drawing board.
I think this SSD is gonna fly off the shelves.
Let's go.
Chip Kids!
Chip Kids, you ready to learn? Let's go! What's good, what's up? I'm Miss Poe. Chip Kids, welcome to our show. All about devices, let's get locked in. Integrate chips, then we're going for the win. Fun experiments with the kids to tie in the STEM. Miss Poe teach us a thing or two with a CHIPKIDS. Let's learn.
Okay, Chip Kids, before we start building, let's talk about why this challenge matters. Every photo you save, every game you play, and every video you stream, it has to be stored somewhere. And the kind of drive inside of your computer makes a huge difference. On one side, we've got the hard disk drive, or HDD. This is a classic. The very first one, built in 1956, was massive. It was 24 inches wide and it only held 3.75 megabytes. That's smaller than one picture on your phone. HDDs are like old record players. They use spinning discs and a moving arm to read and write information. The arms use magnets to mark spots on the disc as ones, magnetized, and zeros, non-magnetized. It can also detect the magnetized spots to read the data back. The pros, they're cheap and can hold a lot. The cons, they break more easily because of all the moving parts. On the other side, we have the solid-state drive, or SSD. This one has no moving parts. Instead of spinning parts, SSDs use flash memory to store info. Inside, tiny circuits trap or release electrons to make ones and zeros. That's called NAND memory. Since it's all electronic with no moving parts, it's faster, smaller, and way more reliable. SSDs showed up in the early 2000s, but by 2010, they were all over laptops. They cost more, but the speed and efficiency, HDDs just can't compete. Today, you get to step into the role of engineers. You'll build your very own SSD brick by brick, balancing cost, speed, and storage. Then you'll pitch your design right here to the circuit board and see if the experts from Micron would invest in your build. Now it's time to meet the parts of your solid-state drive. Each of the pieces on your table represents a real component inside an SSD. And just like in the real world, each piece has a job to do and a cost attached to it. This green base plate, that's your printed circuit board, the foundation everything sits on. Every SSD starts right here. The yellow tiles are connectors. They let your SSD talk to the outside world. One connector is fine for older computers, but the more connectors you add, the faster things move. This red brick is the controller, the brains of the drive. It manages all of the info moving in and out of the memory. No controller, no SSD. These gray plates, that's power management. They control how much juice your SSD uses and how fast it can wake up. One plate gives you just the basics, but the more you add, the more reliable your SSD gets. These orange bricks are NAND memory. That's your permanent storage. It keeps everything saved even when the power's out. Each brick holds 128 gigs. Finally, we've got DRAM. That's your super fast temporary memory. It's where data hangs out for a second before moving on. That's how your computer keeps its speed. Each brick, a solid 16 gigabytes. Every choice you make matters. More NAND means more storage, but higher cost. More DRAM makes it faster, but eats up your budget. It's up to you to find the perfect balance. Now that you've seen what each building piece represents, it's time to put it all together. You and your team are going to work through the same phases real engineers use to design a product. Let's go.
Marketing.
First, you'll have to understand your customer. You'll have a budget of $150 to design an SSD for gamers. Talk with your team. What do you think are the most important features of a gamer's SSD?
Gamers need the best of the best.
They're very picky.
We have to make the best SSD we can.
For gamers.
Next, it's time to design your SSD.
Architecture.
We'll take the priorities for the customers and translate it into different components. This will be the blueprint for your next phases.
Which of these pieces would affect storage?
There's two that affect storage, NAND memory and DRAM.
We gotta invest in that.
Remember, we have to stay in budget. Hello, I have the calculator.
Now comes shopping.
Procurement.
Use your worksheet to choose your pieces to calculate the total. Add them up to get the cost of your SSD.
I hate shopping.
I'll make our list. Well, we have to have the base plate.
These yellow tiles are the connectors. We're gonna need 3 of those.
We're getting 4 red bricks.
4 red bricks. That's a total of $32.
32, got it.
The orange bricks are NAND memory. That means permanent storage.
Let's do 4. Finally, the blue bricks. That's DRAM.
We're gonna need a lot of those.
I think maybe 2 is fine.
Our total is 146.
We're under budget.
I need more power.
We could always go over budget.
I have my dad's credit card.
So what do you want me to add?
Let's add 1 more NAND and 1 more DRAM.
All right, works for me.
I really hope my dad doesn't find out.
Our final total is $174.
Build.
Take the pieces you selected and carefully place them on your circuit board. Your SSD should reflect the priorities you set back in phase 1.
We could put them like right here, but on the sides.
I'm the power man. Let's put him over on the edge.
Looks good to me.
Build complete.
Finally, the
Quality check.
look at your finished SSD and ask, does it actually match the gamer's needs? Does it match the priorities you set?
Okay guys, do you think this would really work for gamers?
It's got the speed, it's got the storage, it's got everything.
A little over budget, but I think we got it.
Quality check complete.
I think we're ready to present our design.
All right, Chip Kids, your builds are done, your budgets are set, and now it's time for the big moment. Let's take these SSDs to the circuit board and see if the experts at Micron approve the design.
1, 2, 3.
Chip Kids!
In the world of technology, every idea begins with a challenge, and every challenge needs a solution. From laptops and gaming consoles to the phones in our pockets, memory drives our digital lives. But which design has the speed, the storage, and the smarts to stand out? A team of young engineers will step forward with their creation. Armed with budgets, blueprints, and building blocks, they'll pitch their solid-state drive to a panel of experts.
Welcome, Chip Kids. I'm Kathy Amarati.
I'm Curtis Cantley.
My name is Nancy Lamelli. I work at Micron in the Social Impact and Community Engagement Organization.
I'm a professor of electrical and computer engineering and the director of our Microelectronics Education and Research Center.
I'm the Director of Advanced Packaging Technology Development at Micron.
Some designs will impress, others may fall short, but only the strongest ideas will earn a nod of approval. This is the circuit board.
Chip Kids, your SSD is ready. Now it's time to pitch it.
First up is Hunter, who is pitching the marketing angle.
Hello, board. My name is Hunter. Our customer is gamers. Coming from a gamer myself, I know we'll need speed because I hate when my game is lagging, storage to save my progress, and lots of power. I believe that my team put together a great SSD and we're excited to pitch it for you.
Hunter, this is exciting. I understand power is super important, so I'm excited to see what your team has brought.
I think it needs speed so that there's no lag in your game.
Thank you, board. I think you'll be impressed. I'm gonna pass it on to my next teammate.
The stage is set.
Hello, board.
Now it's McKenna's time to explain their priorities and features.
This is what we chose to put on our SSD. Just like Hunter said, storage, speed, and power are the name of the game. Thank you, board.
Thank you, McKenna. I'm really curious to understand how you were able to balance some of the NAND and the DRAM trade-offs that appears you have made.
I'm really interested to see how this fits within the budget.
Thank you, board. I'm going to pass it on to procurement to talk about the budget.
The experts are looking interested, but will the budget line up? Let's hear from Adley.
Hello, board. I'm here to talk about the budget. At the beginning of our planning, we only had 4 NAND memory and 2 DRAM, but we decided that that would only make a mediocre gaming system. So we decided to add 1 more NAND memory and 1 more DRAM. This means that our total is a little over budget at $174 instead of $150.
It's very interesting that you decided to go over budget.
I really appreciate that the team went for a premium SSD to provide the best possible experience for gamers. However, budgets are important, and that leaves me a little bit concerned.
About going over budget, it's fine because we had Imogene's dad's credit card. But thank you for your comments. I'm going to pass it on to our architect.
Hello, board. I'm here to talk about the build. Also, don't tell my dad about that credit card thing. Here's our SSD and design. We put the brains in the middle, our power board on the side, our storage together so they could feed off each other, and to finish we put our connectors on the edge. I think we'll find we have an excellent design.
This is a very interesting build. You talk about the proximity of the memory to itself, and I believe it could be even closer.
I specifically liked how you have the controllers in this location in some proximity with the DRAM, which you want to have fast communication with. So I think this layout helps with that traffic of information. I'm ready to hear the final pitch.
Thank you, board. Time to bring out our closer to seal the deal.
The Micron experts have studied the design, but now it's time for Carson to step in with the final pitch.
Hello, board. We studied the market and we think we made the best SSD for gamers possible. But hey, what do I know? I'm just a gamer. We invested in speed, storage, and power. We may have went over budget, but I believe we made the best SSD possible. I think this SSD is gonna fly off the shelves.
Thank you, Carson. You made this decision very difficult for me. You clearly know your customers. This is a gamer's SSD. However, this is still quite a bit over budget. For now, I'm out.
I think that with a few minor changes to the layout on the board, then this will be the best gaming SSD on the market. So I'm in.
Carson, you are a convincing closer. I'm in. I'm looking forward to seeing this SSD out in the market.
Yeah!
Okay, Chip Kids, let's kick it over to our expert.
Hey Chip Kids, we are back with another interview, and today we get to sit down with Mr. Wren here at Boise State University. Wren, can you tell us what do you do here?
So I work at Micron Technology in Boise, which isn't too far from Boise State University. It's probably only about 10 miles. I started out as an entry-level employee at Micron. Wasn't quite sure what I wanted to do when I first started, but I absolutely fell in love with manufacturing and providing something of value to the community. And they also had just a great career development program there at Micron. So I ended up staying, finishing my degree while working at Micron, but currently what they call a project manager for the operations team. Mm-hmm. We manufacture a product that goes into all kinds of electronics. And the The product we manufacture is called NAND or DRAM technology. And so when you take a picture on your phone, that picture goes somewhere.
Right.
It goes either on your phone or it goes in the computer, goes in maybe a cloud server somewhere, and we make that memory. And so take lots of pictures.
You make that?
Oh yeah, and we make good memory too.
What?
Yeah.
Oh, I love that because I'm a content creator, so I have thousands of
Oh, yeah.
pictures in my phone.
Yeah, the more content you make, the better it is for us.
So we keep
it up.
you.
Oh yeah.
Oh.
Yeah, it's really good.
I see.
Yeah.
Okay, so Ren, can you talk to us about the education and the training at Micron?
Yeah, so Micron has a very robust education assistance program. So all employees at Micron are given an opportunity to either advance their career, advance their education, things that they want to learn and know more about. You can either do that with internal classes at Micron. We have this program called Micron University, or you can take external classes like here at Boise State or other online courses all over the country. And so Micron provides this education assistance for full-time employees. So we're very interested in making sure that all Micron employees have an opportunity to learn and grow and find out more information about what we currently do, and especially about how they can advance their career within Micron.
So what do you do to draw the people in?
I think one of the reasons that people like Micron, number one, they've seen it on either social media or Micron's the largest private employer in Idaho, so it's a little easy in Idaho to get the word out that way. But one of the things that I really enjoy about Micron and how I tell others about Micron is the teamwork that we have within the company. If you've ever played sports, the best teams that you've ever worked on have great teamwork. Everybody helps each other, and that's probably the greatest aspect, the people aspect of what Micron is. And I think that's a big draw for candidates and why they would like to come to work at Micron, because it's very, very supportive that way.
Ren, tell us, how do you make sure STEM feels approachable and fun for every student?
So a lot of times when we give tours, I work with other Micron employees, and we give a lot of tours to STEM kids who want to come and learn more about Micron. And we have a lot of hands-on opportunities for kids to come and learn about what they do. An example might be taking something that kids really enjoy doing already, which is maybe a puzzle or Legos, and they love putting them together and making something out of what initially looks like nothing.
Right.
And so when you look at STEM, it's problem solving and troubleshooting and making something that is usable in the end. And so when we look at, as an example, like a Lego set, it's actually really satisfying to relate STEM to a Lego set, because you're building something that's fun and you can take off, put on, actually now use your own innovation to make something even cooler or more fun. And so STEM is a lot that way, where you can take all the information that you've learned in school, and you can make something more out of what maybe initially might not look like much. So it's really kind of fun that way.
You think I can come?
Oh, absolutely.
Ren, thanks so much for coming in and speaking with me today about Micron. I think you have left some jewels here today.
Thank you for inviting me to come.
Chip Kids! That's a wrap from the circuit board at Boise State University. Today, we learned how hard drives work, why SSDs are faster, and even built designs of our own to pitch in front of the experts at Micron. I'm Miss Pope. Thanks for tuning in to Chip Kids. And remember, stay curious, stay creative, and keep thinking big. Bye!
Let's go, it's a new kind of show that's made for you. Miss Pope teach us a thing or two with a CHIPKIDS. Let's learn.
Hey, do you know what these charges are on my credit card for SSD parts?